lecture, I hope we have understood. We started with the analysis of Hartnell governor. So basically, there are two cases. One is obligatory effect, and second one is a neglecting obligatory effect. So one case we have finished off, and today we will understand the problems also. Okay. Uh, so all this stuff we have already understand. I have already explained you. Okay. So this is the minimum position diagram which we have drawn in the last lecture. I hope you have gone through this. Okay. So this one is for the minimum. This is nothing but a minimum position. Okay. So we have understand. I hope you have understand this how to draw this diagram. Okay. So A1, X1, Y1. Okay. So this is the case number one. Okay. So this is nothing but a mean position, or you can say the mean position diagram. Okay, and then this one is a maximum position, right? Maximum position diagram. Okay, so this was the case number one which I have explained you. Case number, what was the case number one? The case number one was what is this X? X is nothing but the length of the vertical arm, right? And what is Y? Length of the horizontal arm. Okay, so in case number one we were considering the obligatory effect. Case number means what? Considering what we have studied, considering obligatory effect, right? Obligatory effect. What do you mean by the obligatory effect? Means what? This x is not equal to x1. x1 is not equal to x. Means what? Even if it is a negligible difference, but your x1 and x are difference, and y is not equal to y1. So this is y1 and this is y, x and x1. Okay. So we are not considering this. That is y is equal to y1. We are considering y is not equal to y1. Okay. And secondly, mg, we are considering the effect of mg also. Means what? If you take a moment about this point o, if you take a moment about this point o, what we had got? Mg multiplied by a1, mg multiplied by a1, right? So I mean to say that we have considered each and every parameter, right? So that was called as the obligate effect. So in the question, the problem may come with the help of a obligatory effect or without obligatory effect. Okay, and then we have gone through the derivation for minimum and maximum position. So now I will not again. Then we have got this one equation. I am just revising within a short splitter. H is equal to R2 minus R1 upon Y upon X. So this is very important equation, or you can say the formula what we have got. So use this into the while solving a problem. H is equal to R2 minus R1 Y upon X. Okay. And what one more formula you have got? Okay. One more formula I've got is K. What is K? K is nothing but the S2 minus S1 upon R2 minus R1 upon X. So this is nothing but the second equation. This is nothing but the second equation what we are using. So considering the obligatory effect, we are getting this K is equal to S2 minus S1, R2 minus R1 upon X upon Y. Right? I hope it is clear to you. Okay. Now case number two. Let us understand that case number two very easy, and then we'll go to the problems. So neglecting, now this is the minimum position diagram, right? See this mg is inward, mg is inward. So mg is moving inward, and this R1 point where what is R1? Where you have mg plus s1 upon 2. So this is nothing but a vertical downward force. So this is called the minimum position. So this minimum position diagram, so what you are considering in the neglecting the obligate effect means what? You are considering x1 is equal to x2 is equal to x, and y1 is equal to y2 is equal to y. Okay, and the movement due to the weight of the balls, that is mg, is neglected. Means what? We are not considering this movement, that is mg multiplied by a1. Is it correct, guys? Have you understand the difference between the two cases, obligate effect and neglecting the obligate effect? Okay. Now for minimum position. Now for minimum position, can you tell me taking moment about O? So if you want to take a moment about the O, what is a moment? Can you tell me what is a moment? We are considering clockwise positive, na? See, this is the clockwise positive, and this is the anti-clockwise negative, right? This is what you have to remember. So you can see what you are getting. This mg plus s1 by 2, mg plus s1 by 2, right? So what we are getting? Mg plus s1 by 2 into y. Now basically what actually equation will be mg plus h1 divided by 2. So this force, what is the multiply by distance into y, into y1, right? Then this is nothing but a clockwise minus what is this fc? fc1 multiply by, now this fc1 is anti-clockwise. What is the distance between this point 2 and fc1? x1. into x1, and mg we are neglecting, right? Mg we are neglecting. See, in last case we have considered mg, in this case we have is equal to 0, we are neglecting mg. Okay, but as I earlier said that x1 is equal to x2 is equal to x, and y1 is equal to y2 is equal to x. So instead of y1 I am writing y, and instead of x1 I am writing x. So basically, in the problems, if you consider the obligate effect, you have to calculate y1 and x1. I will show how to calculate. But if you are neglecting, you can directly, you have been given what is y and what is x1. You have been given, so directly consider that. Now message me, have you understand the difference? Have you understand the difference? Please message me, okay, if you have understand the difference. How to take, and then you have to take the movement. See, basically, Hartnell governor is all about the taking movements only. Is it clear? Please message me fast if it is clear. Is it clear the difference and how to take the moment? So for this is the minimum position diagram. Yes, okay. So for minimum position diagram, I have got this equation. Mg plus s1 by 2, this is anti-clockwise, this is clockwise. So clockwise negative, okay. So take the moment. Now taking the moment, then I am just modifying it, mg plus s. Shift this 2 towards this side, that is the right side. Shift this y towards this right side, okay. So shifting, you will get this equation, mg plus s1 is equal to fc1 up into x upon y. Okay, so let us call this equation number 6. Okay, now you have got this equation. See, in last case, you have also got equation of mg, that is a mg multiplied by a1. You might have got mg into a1, but here we are neglecting the weight of fly mass, because we are considering that weight of fly mass is very negligible as compared to the weight of the another parts of the governor, right? And then we are taking x1 is equal to x, y1 is equal to y. Very important. See, it simplifies the problem. Okay, next, for maximum position. Now anybody, can you tell me for maximum position what will be the, yes, what will be the equation for maximum position? See, now this is a maximum position diagram. Now see, these two diagrams are fixed, constant, three diagrams. You have to remember this diagram. See, mg is outward, and this y point is upward. Okay, yeah, can anybody tell me what will be the equation for maximum position? For neglecting the effect, what will be the equation? See, na, mg plus s2 divided by 2 multiply by, now this is clockwise, multiply by this y2, but I will take y. Why I will take y? Because y2 is equal to y. You know that y1 is equal to y2 is equal to y. We are touching the obligate effect. Okay. Yes, and then fc, then plus fc2 multiply by what? It should be x2, but I am taking x, that is equal to 0, right? So this is the equation, and this mg we are neglecting. Guys, very important. You have to write down this equation. If you have to solve the problems, you should be able to write this moment equation. Now tell me, are you able to write the moment equation or not? Okay. Okay. So I'm getting this mg plus s2. Okay. So mg plus s2 upon y is equal to mc2 into x. So just I have modified this. I've got this equation. Okay. Is it okay? Okay. And then I got this equation number 6. I just modified it. R2 मी इकडे घेतला, multiply by xy. So I got these two equations. So equation number 6 and equation number 7. So I got this equation 2. Okay. Now rest is same. Use the two equations, solve the two equations. So basically you got a two equations. Now see, subtracting equation 4, equation 6 from 7. Okay, so what you are getting? Basically what we want, S2 minus S1. What is S2? Force, spring force at maximum condition. S1 is spring force at a lowest condition or a minimum condition, right? So I'm getting this equation S2 minus S1, right? So I'm getting this equation. Now basically we know that we have already derived what is S2 minus S1, H into K. This is the equation we have already derived, and H is equal to R2 minus R1 upon Y upon X. This is also we have derived. Okay. So from this equation, that is from this equation, and using this equation and this equation, what I am getting, K is equal to S2 minus S1 upon H, right? But what is S2 minus S1? 2 into 2 FC2 minus FC1 upon R2 minus R1 into, and what is this? What is this X by Y? What is this H? What is this H? R2 minus R1 upon Y upon X. So it becomes X upon Y square. Okay. So basically, I hope you understand. In this equation, K is equal to S2 minus H1. Put this, and this. Okay, and you have got this equation. So this is the final equation. This is the final equation for a Hartnell governor considering an obliquity effect. Now tell me, have you understood how you got this equation? Okay. Now once you got this equation, let us move forward to the last part and then we will solve the problem. Is it clear? Have you got this? Have you understand this? Fc2 minus Fc1 upon R2 minus R1 X upon Y square. Okay. Now what you should understand and what you should remember. Unless otherwise stated, the obligating effect of the arms and the movement due to the weight of the ball is neglected in actual practice. Means when you are solving a problem, if they mention neglect the obligating effect, you will neglect. But if they mention consider the obligating effect, you will consider. But if they do not mention anything, we will neglect the obliquity effect because that will make the problem easy. Okay, is it clear? Now when friction is taken, now already in the portal government we have understand about the friction. See, when the sleeve moves upward, what happens? When the sleeve moves upwards, okay, the friction force weight is downward mg, so it will get added. When the sleeve is moving downward, okay, frictional force gets upward, weight is downward, so it is getting minus. Okay, so this is what we have understand. Okay, is it clear? Is it clear or not? Okay. So similarly, when the friction is taken into the account, the weight of the sleeve may be replaced by mg plus minus f. So mg plus minus f. So this is same as the Porter governor. So you know, when the sleeve is movement is upward, it will become plus. When the sleeve movement is downward, it will become minus. Okay, that is clear. Now, the third and very, very important point before I go to the problem, the centrifugal force Fc for any intermediate position, that is between the minimum and maximum position, may be obtained as discussed below. Now, very, very important. Okay. Now what you have equation? See, basically what you should understand, I will give you one graph. I will give you one understanding. Okay. What you should understand. Let us say this is a maximum position. Guys, okay? Beta, I will write some derivation. I write some basic maximum position. Then I will call it as an intermediate position. Intermediate position means what? Mean. Okay. And then I will call it as a minimum position. Okay. Now for maximum position, what are the notations? What are the notation? Centrifugal force will be Fc2, right? Then radius of rotation will be R2, spring force will be H2, height will be H2, right? For this you will have Fc, R, S and H. And for minimum position, what you will have? Fc1, R1, S1 and H. Okay? Comma, this comma, this comma. Guys, have you understand this? This is what you have to remember. Now, maximum, mean and mean position. Okay? So you have to understand this notation. For maximum, we have Fc2, R2, S2, H2. Fc, R, S, H. Fc1, R1, S1, H1. Right? Is it clear? Now basically what you have to understand is that now basically what is your equation, what we have get the final equation for spring stiffness? K is equal to 2 into Fc minus S1, Fc1, 2 into Fc minus Fc1 divided by R2 minus R1. This is what we have got, X upon Y square. Now what is this is between what? This is between the maximum and minimum position, right? This is between maximum and minimum position. Okay. Now, if I say you calculate the spring stiffness, they will see this is a spring stiffness between the Fc2 minus Fc1. That is a maximum and minimum position. Now, each time you don't need to do the derivation, right? If I told you calculate the spring stiffness for minimum and intermediate position. So how will you calculate? Can anybody tell me? Minimum and intermediate position. See, this is what maximum position. This is what a mean means intermediate, and this is a minimum position, right? Now for this, see, minimum position is below mean, maximum position is above the mean. So minimum is always less than maximum and minimum, and mean is greater than minimum and greater than maximum. So tell me, how will you write this equation? How will you write this equation for this minimum and sorry, mean and minimum position. How you will change the equation? Very simple. 2 into, now for minimum, what is for minimum? What is FC? What is FC? FC1, right? But for mean position, what is FC? FC. But mean is greater than mean, so you can write FC minus FC1, right? You will write FC minus FC1 divided by this R2 will become R minus R1 into X minus 1. This will be constant. So this is equation for maximum and minimum. This is equation for minimum and intermediate. And if you want the equation between the mean, if you want the equation between the maximum and minimum, now anybody tell me how will you write the equation for maximum and mean position? Yes, k is equal to 2 into, see, one equation I have derived and I have to write the equation from for maximum and minimum मी derive केलं. एकदा मी मिनिमम आणि मीन आणि मिनिमम साठी काढतोय, एकदा मीन आणि मॅक्सिमम साठी काढतोय. ओके, फक्त काय करायचंय, FC2 च्या ऐवजी FC रिप्लेस करायचंय. आता मला सांगा, तुम्हाला जर हे कळलं असेल तर मीन आणि मॅक्सिमम साठी इक्वेशन कसं लिहायचं? हॅलो हॅलो, anybody can speak up please. How will you write this equation? See, FC2 minus FC1, FC minus FC1. Have you understand how I have written? How will you write for, please answer fast.
FC2 minus
Write this
FC.
for the, yes, FC2 minus FC divided by what?
R2 minus
Divided
R.
by R2 minus R, yes, into X minus, I hope you have understand this. So this is what I was expecting, okay? So this is what you have to understand, okay? So for minimum and intermediate position, you have FC minus S1. For intermediate means what? Mean position. You have FC2 minus FC and R2 minus R. So this is a change, right? Because guys, you have to understand that this is maximum, mean and minimum position. So maximum we have FC2, FC and FC1, R2, R and R1. So basically you can see that R2 is greater than R2 is greater than R and R is greater than R1. So accordingly you have to shift it, okay? I hope you have understand this, okay? And then all the equations. From equation what you will get? You will get this final relation. So sometimes they will ask you in the exam, prove that FC2 minus FC1 upon R2 minus R1 is equal to FC minus FC1 upon R minus R1 is equal to FC2 minus FC, because left hand side is equal and so right hand side will be equal and you will get this final relation, right? Okay, you can see this. So you can see here what is left hand side, K, and here also you have K. Okay, so if left hand side is equal, this X upon Y square will get cancelled. 2 will get cancelled, 2 will get cancelled. So this is equal to this. Now message me fast. Have you understand the Hartnell governor? I think this is slightly complicated as compared to the Porter governor. But now once I solve the problem, you will understand more. Just message me. Have you understand? Have you understand Hartnell governor? Shall I move to the numericals? Have you understand the analysis? आता तुम्ही जे अनालिसिस शिकलाय त्याच्यातनं तुम्हाला प्रॉब्लेम सॉल्व्ह करताना काय काय लागणार आहे ते आपल्याला बघायचं आहे. ओके, सो द प्रॉब्लेम्स ऑन पोर्टर गव्हर्नर आय हॅव ऑलरेडी सॉल्व्ड. लेट अस सॉल्व द प्रॉब्लेम्स ऑन हार्टनेल गव्हर्नर. ओके, नाउ मेसेज मी ओके इफ यू हैव अंडरस्टैंड द theory of the Hartnell governor, so I can move on to the problem section. Yes, why today students are less due to the network issue? Yes, Dilsich or any Yash, why count is less today? Okay, network issue is there, sir. Okay, maybe the network issue is there. Okay, no issue. Okay, I will make a video if possible. And okay, so guys, now very important. Now maybe what I'm saying, maybe 50% or maybe 60% you have understand what I've taught you in the analysis. Why? Because you are not writing after me, maybe. Okay, but now remaining 40% you will get clear. Remaining 40% you will get clear while we are solving a problem. Okay, so the Hartnell governor have a central sleeve spring and two right angle belt and levers moves between 290 rpm and 390 rpm. Okay, So basically, they have given you 290 and 310. So you can understand N1 minimum. So now you know that N1 is equal to 2 pi, sorry, omega 1 is equal to 2 pi N1 upon 60, right? So this is a basic formula. No need to write this formula. Directly put into the calci and find out the answer. Omega 1 is equal to 30.4 radian per second. Okay. Next, they have given you N2 is equal to 310 rpm, omega 2 is equal to 32.5 radian second. Okay. Similarly, omega 2 is equal to 2 pi N2 upon 60 radian per second. I think no need to help you to understand this. You know this. Okay. For a sleeve lift of 16 mm, for a sleeve lift, now in the analysis, what I have explained you, what is sleeve lift? Now we know that for a minimum position, sleeve lift was H1, and this H1 was equal to the compression of the spring. This H1 was equal to the compression of the spring. If you have not understand the analysis, at least remember this. When they are saying for a sleeve lift of 60 mm means what? H is equal to 60 mm. That is a total sleeve lift. Total sleeve lift, and you know that H is equal to H1 plus H2, right? What is H1? Sleeve lift at minimum position. What is H2? Sleeve lift at maximum position. And okay, and one more important point, we are considering H1 is equal to H by 2 and H2 is equal to H by 2. Okay, this is we are assuming. If not given in the problem, the problem मध्ये दिलं नसेल, so basically assume H1 is equal to H by T. So means what? H1 is equal to 8 mm and H2 is equal to 8 mm. We are assuming. Okay, slightly we have to assume something. Okay, next, the sleeve arms and the ball arms are 80 mm and 110. Now tell me anyone, what do you mean by the sleeve arm? Sleeve arm means vertical arm or horizontal arm? So what I mean to say, what is X and
Horizontal.
what is Y? Yeah, sleeve arm means horizontal arm. Very nice. And ball arm means what? Vertical arm.
Vertical.
So why? Yeah. So why they have given 120 and why? See, now if you look clearly, if you focus clearly in the problem, you will understand Hartnell governor. Hartnell governor is not tough. See, when I was explaining you the derivation, you feel like it is very tough. You are not understanding. But when you solve the problem, it is very easy. See, so y is equal to 80 mm, x is equal to 120 mm, and the levers are pivoted at a 120 mm from the governor axis. The levers are pivoted at a 120 mm from the governor axis. Means what? Levers means what? You know, na? This is a position. This is a position. Let us say this is nothing but a pivot point, and this is a governor axis. So distance between this governor axis and the levers which are pivoted, this is nothing but a r. So they haven't given you R1 and R2. They have given you the levers are pivoted at a 120 mm from the governor axis. They have given you R. Okay. And mass of the each ball, they have given you 2.7 kg. Okay. The ball arms are parallel to the governor axis at lowest equilibrium position. Now, very important, guys. See, basically I have explained you the two diagrams. Which are the two diagrams? Which are the two diagrams I have explained you? Okay. I have to slightly move again backward. I will move to that slide. Okay. This is a this is the, you can say, two condition. What is this two condition? This is a minimum position diagram, and then this is a maximum. In minimum position, what you have understand, mg is inward, and in maximum position mg is outward. This point, that is a r1 point. R1 point is nothing but the, that you can say, where the sleeve arm is connected. It is downward and it is upward. Okay, so this is minimum and maximum position. But there was a third position which I will explain you. What was that third position? What was that third position? Let us understand the third position. Okay, this was the third position. Now, third position means what? This is nothing but a mean position. So, in mean position, what you understand that this x, what you understand from this, the ball arms are parallel to the governor axis. What, see, x is parallel to this governor axis. X is parallel to the governor. What, see, this is the governor axis, na? This is the governor axis. Okay, and ball arm means what? This x. X is what? Vertical arm. X is vertical arm. See, the vertical arm means what? Ball arm. Now, in the problem, they have mentioned that this ball arm is parallel to the governor axis. So now, guys, and they are saying that this is the lowest equilibrium position. Lowest means what? Minimum. So guys, they want to say that this mg is not like this. This mg is not like this. Means what? This mg is not inward, but this mg, sorry, this ball arm is parallel to the governor axis. Means what? They have given you, they are saying that lowest position is the mean position. Is it okay? Is it okay or not? Have you understand this or not? So this is what you have to understand. So basically, first of all, you have to understand from the three cases, which two cases they have given you. Okay, guys, it is clear. So let's move further. Okay, now, okay, now this is minimum position. Now I have drawn the two diagrams. So basically, guys, you have to draw the two diagrams. It is very, very important. Now this is a minimum position and this is a maximum position, or you can call it as a lowest position. Okay. Now they have said in the problem. Now you will say that why this mg? Now this is a ball point, na? This is a ball point, and this is a ball point, right? Now you will say that, sir, why this? Have you understand why I have taken this minimum position? Because they have mentioned that this x is parallel to this governor axis. समजलंय बाळांनो तुम्हाला? ह्या दोन्ही पोझिशन कळल्यात तुम्हाला मी असं का घेतलं, ही मिनिमम पोझिशन का घेतली आणि ही मॅक्झिमम पोझिशन मी का घेतली. ओके, द रेस्ट इज सेम. प्लीज मेसेज मी, हॅव यू अंडरस्टँड ऑर नॉट वाय हॅव टेकन दिस. तुम्हाला क्लिअर झालंय का बाळांनो हे? कारण त्यांनी प्रॉब्लेम मध्ये मेन्शन केलंय की तुमचा जो बॉल आर्म आहे म्हणजे एक्स हा तुमच्या गव्हर्नर ऍक्सिसला पॅरलल आहे. दिस इज द गव्हर्नर ऍक्सिस आणि ही तुमची मिनिमम पोझिशन असं त्यांनी प्रॉब्लेम मध्ये मेन्शन केलंय. जर मेन्शन केलं नसतं तर मी काय घेतली असती? मिनिमम पोझिशन घेतली असती. म्हणजे माझी डायग्राम कशी आली असती? माझी डायग्राम ही अशी आली असती ना. माझी डायग्राम कशी आली असती? ही अशी आली असती. हा आतमध्ये आला असता आणि हा असा डाऊनवर्ड आला असता. R1 पॉइंट आणि हा mg पॉइंट आणि हा fc पॉइंट आणि हा x आणि हा y. ओके, हा θ1, हा θ1 आणि हा माझा O पॉइंट. So this would be my position, but this is not the case. In next problem, that is the case. Okay. So now basically, what you have to understand, n1 is given, n2 is given, m is given. Now r1 will be equal to r. Now we know that, you know that what is a r? R is nothing but the this distance. Okay, now this distance is nothing but the r. Now this is the lowest position. This is the lowest position, means this is equal to the minimum position. So that will be equal to the mean position. So for minimum position, r is equal to r1. So I am considering r1 is equal to r. But what is r2? What is r2? This is r2. This r2 we don't know. We have to calculate. Okay. इज इट क्लिअर गाईज? जर तुम्हाला ही त्यांनी मिनिमम पोझिशन म्हणजे मीन पोझिशन दिली नसती तर तुम्हाला R1 सुद्धा कॅल्क्युलेट करावा लागला असता. ओके, पण आता त्यांचं म्हणणं आहे की मीन पोझिशन इज इक्वल टू युअर मिनिमम पोझिशन. सो दॅट इज वाय R1 विल बी इक्वल टू R. इज इट ओके? बिकॉज एवढा फंडा लक्षात ठेवा, मॅक्स, मीन आणि मिनिमम. मॅक्सला काय असतं R2, मीनला असतं R आणि ह्याला असतं तुमचं R1. नाव this mean is your minimum position. Means what? Mean is equal to mean position. So that is why R is equal to R1 and I have to calculate R2 only. Is it okay? So let's see. And this diagram I have already drawn as usual. So this is a O point. This is a O point. Okay. And this is a ball point. Now guys, in the problem, very, very important. In the problem, they haven't mentioned consider a obligating effect. They haven't mentioned consider the obligatory effect. So what I will do, I will neglect. And when you are neglecting obligatory effect, x1 will be equal to x2 equal to x and y1 will be equal to y2 equal to y. Okay, and we are not considering the mg. We are also neglecting this mg equal to 0. Okay, so that is why जर तुमच्या लक्षात आलं असेल तर इथे बघा, इथे मी कुठेच mg दाखवलेलं नाहीये. असं मी mg कुठे दाखवलंय का? इथे mg दाखवलंय का? नाही, कारण आपण तो निग्लेक्ट करतोय. सो आय हॅव मेक दिस प्रॉब्लेम व्हेरी सिम्पल. ओके, आता गाईस मला सांगा, तुम्हाला हा प्रॉब्लेम समजलाय का? इफ यू हॅव अंडरस्टँड, वी विल मूव फॉरवर्ड. हॅव यू अंडरस्टँड दिस बोथ द डायग्राम्स? So this is I call it as a minimum. I will call it as a maximum. Have you understand? Yes. If you have understand, please tell me, otherwise I will move forward. Yes, Pratik, Raj, Dilshij and all, have you understand this problem definition? Yeah, very, very important. So, yeah. Try to see, I will be giving you the assignment. Try to solve assignment on your own at least. Now, basically, first step, FC1, calculate FC1. Now, guys, see how to calculate. Right here, max, mean, and minimum. So, for maximum, we have FC2, R2. One second. Huh? See how to start with maximum, mean, and minimum. Okay. So for maximum position, we have FC2, R2, S2, and H2. Here we have FC, R, S, and H. And here we have FC1, R1, S1, and H1. Right? So now basically this mean and minimum position, these are one and the same. So I have to calculate FC2, R2, S2, H2. Similarly, I have to calculate FC1, R1, S1, and H1. Okay. So this all parameters, guys, I have to calculate. Right. So first of all, I will calculate FC1. FC1 means what? FC is equal to mr omega square. So FC1 will be equal to m is constant, R1 omega 1 square. FC2 will be m is constant, R2 omega 2 bracket square. So this is very, very simple calculation. Okay. So calculate, you are getting 299.43 Newton. Okay. Now I have, see, we have a time limit. So I have directly calculated. Next, H2. What is the formula for H? This is already we have derived. Okay. This is already we have derived. What we have derived? Remember this formula. If you, even if you don't understand the derivation, remember this. H, that is the total slip, is always equal to R2 minus R1 into Y upon X. This is the formula which you have to always remember. Okay. So now, so from this you will get R2. Actually, तुम्हाला R2 मिळेल. So what is R2? R2 is equal to R1 plus H into XY. R2 is equal to R1 plus H into X upon Y, right? हे तुम्हाला मिळणार. बरोबर ना बाळांनो? H is equal to R2 minus L1 upon Y upon X. So R2 is equal to R1 plus H into Y upon X. So basically बघा, R1 मला माहिती आहे. What is R1? 120. H किती आहे? 16. X किती आहे? 128. So I am getting R2 is equal to 140 Fresnel, right? Because I know H, I know R1, I know Y, I know X. See, H is equal to R2 minus R1, Y upon X. Okay. You know H, you know R1, you know Y, you know X, you will get R2. Okay. So I am getting R2 is equal to 144 mm. Right. So next, what is FC2? M2 M R2 omega square. Okay. So I am getting 2.7, and so I know M is constant. R2 now we have calculated, omega 2 you know, so you are getting FC2. Now you can see that FC2 is equal to 410.67 Newton. Guys, okay? Okay. Now next. Now consider this minimum position. Now I want to answer from your side. This is a minimum position diagram. Taking movement about point O. Chalo. Now consider this minimum position diagram. Neglecting the obligate effect. चलो तुमच्या साईडनी कोणीतरी मला सांगायचं मुवमेंट कसं घेणार. आतापर्यंत तुम्हाला कळलं असेल मुवमेंट मध्ये काय येणार आहे. mg आपण निग्लेक्ट करतोय. x is equal to x1 is equal to x2, y is equal to y1 is equal to y2. Very, very important. Okay. चलो. Now tell me, anybody from your side, ह्या मिनिमम पोझिशन साठी मुवमेंट घेऊन दाखवा मला. तुम्हाला कळलं
mg plus s1 by 2 into y and is equal to fc1 into x.
Plus mg plus s1 by 2 into y. Actually it should be y1. Huh? You understand that actually it should be y1, but we are neglecting the obligate effect. Okay. So he is right. mg plus s2 upon y, very sorry, into 2 into y. Yes. पुढे काय सांगितलं?
Equals to fc1 into x.
Plus or minus?
Minus or equal to?
Minus, yeah, minus or equal to, yes, fc1 into x. Okay. So this is the moment. Now guys, have you understand why I have taken minus? Because I have taken it as a anti-clockwise and clockwise. Okay. And if there was a mg, if there was a mg, so mg multiplied by a1, that was a another moment, but mg is not there. Okay. So I hope you have understand this and very okay. So mg plus s1 upon 2 into y is equal to epsilon into x. So now here take m is equal to 0. Now what is m? M is equal to mass of the sleeve. Mass of the sleeve. Now guys tell me why I have taken m is equal to 0. Why I have taken mass of the sleeve as a 0. So mass of the sleeve not, sorry not mass of, m is the mass of the sleeve, right? Mass of the sleeve. m is the mass of the sleeve which is acting at that point. हा जो तुमचा पॉइंट आहे ना, या पॉइंटला त्या स्लीव वरती. Okay. Why I have taken this 0? Because m is not given. M is not given in your problem, guys. M is not given in your problem, so that is why consider m is equal to 0. म्हणजे m तिथे नाहीये. म्हणजेच हा जो तुमचा पॉइंट आहे, कुठला पॉइंट? हा जो तुमचा r पॉइंट आहे, याच्यावरती फक्त S1 आणि S2 हे दोन फोर्स ऍक्ट होत आहेत डाउनवर्ड, बरोबर? S1 आणि S2 हे दोन डाउनवर्ड फोर्स ऍक्ट होत आहेत कुठे? तर ह्या पॉइंट आर ला. पॉइंट आर ला म्हणजे इथे तुमचा तो स्लीवचा पॉइंट आहे तिथे, बरोबर? कारण एम किती आहे हे त्यांनी दिले नाहीये प्रॉब्लेम मध्ये. ओके. So this is what you have to understand. So from this m I am taking 0. So if m is equal to 0, capital Mg is equal to 0. So 2 into epsilon into x upon y. Okay. So I am getting h1. So you are getting h1. So what is h1? H1 is nothing but the spring force. What is h1? Spring force. Spring force exerted in downward direction. Exerted in downward direction at minimum position, right? At minimum position. Similarly, S2 काय असणार आहे? मॅक्झिमम पोझिशनला आणि S काय असणार आहे? मीन पोझिशनला, बरोबर? मला सांगा इथपर्यंत सगळ्यांना क्लिअर झालं का? ओके. आता जर इथपर्यंत क्लिअर झालं असेल तर आता मला कोणीतरी मॅक्झिमम, नाव लेट अस कन्सिडर अ मॅक्झिमम पोझिशन. आता चला मॅक्झिमम पोझिशन साठी सांगा कोणीतरी मला. चलो मॅक्झिमम पोझिशन साठी मूवमेंट सांगा. टेकिंग मूवमेंट अबाउट दिस इज द पॉइंट ओ. रिमेंबर दिस इज द पॉइंट ओ. नाउ टेक अ मूवमेंट फॉर द मॅक्झिमम पोझिशन. चलो मॅक्झिमम पोझिशन साठी मूवमेंट घ्या. एनीबडी? अरे बोला ना, हे जर तुम्हाला नाही कळलं ना बाळा तर तुम्हाला पुढे काहीच कळणार नाही.
mg plus s2
Yes.
upon 2 in
mg
mg plus
plus
s2
s2 upon 2
upon 2 into y
multiply by y.
minus fc2 into x is equal to
Yes,
0.
मायनस या म्हणजे थोडक्यात FC2 इंटू एक्स. ओके. आणि इथे mg, जर इथे mg असता, जर इथे mg असता तर तो आला असता तुमचा प्लस mg इंटू a2 जे काय असेल ते, पण आता तो नाहीये. ओके. फॉरगेट अबाउट दॅट. ओके. सो चलो. सो mg प्लस s2 इंटू y2 इज इक्वल टू, बेसिकली दिस y2 इज इक्वल टू व्हॉट? y. ओके. इंटू FC2 इंटू एक्स आणि mg इंटू a2 म्हणजे हा 0 आहे, म्हणजे हे नाहीच आहे. ओके. म्हणजे इक्वेशन, तर थोडक्यात हे इक्वेशन मी सिम्प्लिफाय करतो. mg प्लस s2 डिवाइडेड बाय 2 म्हणजे जसं ह्यांनी सांगितलं इज इक्वल टू y इंटू FC2 into x, right? So m is equal to 0. M is equal to 0 because m they have not given mass of the sleeve. Mass of the sleeve they haven't given. So m is equal to 0. So I am getting S2. S2 is equal to, I am getting S2 is equal to 1232. Now guys, you have understand that as per the theory, S1 is the spring force exerted at minimum position. S2 is the spring force exerted, and as you have understand the theory, S2 is always greater than S1 because at S2, the equilibrium speed is more as compared to the S1. So S2, the spring force will be obviously greater than the S1 because the compression is also more. Okay. So S2 is greater than S1 as we have understand this. Okay. Is it clear? Now next, we know what is the stiffness. What is the stiffness? K is equal to S2 minus H1 divided by H, right? This is the stiffness. This we have already derived. आता फॉर्म्युला कसा आला मी तुम्हाला ऑलरेडी सांगितले, because we know that F is equal to K into X, right? Spring force F is equal to K into X. So K is equal to F upon X. and F is what? Force. X is what? Edge. And what is F? H2 minus H1. Okay. So remember this formula, K is equal to S, don't consider this S. So K is equal to S2 minus S1 upon H. Okay, I will write here, K is equal to S2 minus S1 upon. See, spring stiffness is always constant. K is always constant. Stiffness, because see, whenever you, guys, very important to understand, whenever you are designing a spring, you are keeping a stiffness constant. So whether for N1 position, for N2 position, and for whether it is a N1, N or N2, whatever may be the speed, your K will be constant, right? Only what will change, your S2 will change, your S1 will change, and divided by H, this sleeve lift, okay? So I am getting this answer, K is equal to 20.86 Newton per mm, okay? Because you know that K is equal to F upon X, force upon deflection, Newton per mm. Now, guys, I have completed my this problem. I will move to the next problem. Now, tell me, have you understand how to solve the problem? Okay. So basically, in the problem, they have told you to calculate. What they have told you to calculate? The load on the spring at the lowest position and the highest position means what? They have told you to calculate S1 and S2. Load on the spring at the lowest and the highest position means what? S1 and S2. And stiffness. Stiffness means what? K. So I have calculated all three. Now message me. Have you understand this? और मग सांगाल तुम्हाला समजले की नाही? समजले का सांगाल का? प्रॉब्लेम कसं सॉल्व करायचं कळलंय तुम्हाला हा प्रॉब्लेम? ओके. ओके, थँक्यू सो मच. आय होप यू हॅव अंडरस्टँड दिस. चलो नेक्स्ट प्रॉब्लेम. आता हा प्रॉब्लेम आपला पूर्ण सॉल्व करून होणार नाहीये, लक्षात घ्या. थोडासा सॉल्व होणार आहे, बाकी उरलेला आपण उद्याच्या लेक्चर वगैरे बघूया. But we will at least start here. So in a Hartnell governor, the mass of each ball is 1 kg. So M is given, concentrate. Okay. The length of a vertical arm of a bell triangle is 100. Vertical arm means what? X. Let's say vertical arm means X, horizontal arm means Y. Don't change the notation, guys. Very, very important. Don't change the notation, what I have taught. Otherwise, you will get confused. Fix in your mind. Capital M, small m, capital X, sorry, X, small y, X1, Y1, R1, R2, S1, S2, K. Fix all the notations. Okay. Next, the distance of fulcrum and the horizontal arm. Y is equal to 50 mm, so 0.05 meter. Next, R is equal to 80 mm. See, the distance of a fulcrum of each belt cantilever is 80 mm from the axis of governor. See, the distance of a fulcrum means what? This is a pivot point, na? This is a pivot point. Let us say this is a you can say this is a ball मास. सो या मास मधनं जी काय ऍक्सिस जाणार आहे, या मास मधनं जी काय ऍक्सिस जाणार आहे आणि ही तुमची गव्हर्नर ऍक्सिस, त्याच्यामधलं जे डिस्टन्स असतं ते आर असतं. रेडियस ऑफ रोटेशन मीन्स व्हॉट? रेडियस ऑफ रोटेशन ऍट मीन इक्विलिब्रियम पोझिशन एन. ओके. अँड ऍट R1 you will get N1, at R2 you will get N2. So this is what you have to remember. Okay, so they have given R is equal to 80 mm. The extreme radius of rotation of the ball are 75 and 112. Means what? They have given R1 and R2. Means what? See, R1, sorry, R2, R and R1. They have given this all. They have given you R2, R and R1. So they have given all the three conditions. That is the N2, N and N1. So when the Hartnell governor is at minimum position, mean position and maximum position, what is the corresponding radius of rotation? They are given. Okay, so that is why again and again I am telling you that remember this condition: maximum, minimum, and sorry, mean and minimum. So maximum is what? N2, N and N1. So FC2, R2, S2, H2, FC, R, S, H, FC1, R1, S1, H1. Remember this always. So this is greater than this is greater than this. Is it okay? If you remember this sequence, you will not get confused. Okay. Next, the maximum equilibrium speed is 5% greater than the minimum equilibrium speed, which is 360 mm. So this statement is very, very important. 5% greater than maximum means what? They have given N1 is equal to 360 rpm, and they are saying that okay, omega 1 is equal to 2 pi n 37. Now they are saying that omega 2, they are saying that omega 2 is equal to 1.05 times omega 1. Means what? The maximum equilibrium speed is 5% greater than the minimum equilibrium speed. Means what they are saying that N2 is equal to 5% of N1. Now, when you are saying that N2 is equal to 5% of N1 means what? N2 is equal to 1.0.5 times omega N1. हे गणित तुम्हाला समजतं ना बाळांनो? हे कळतं का तुम्हाला? N2 is equal to 1.05 times N1. Have you understand this? जर त्यांनी असं म्हटलं असतं 5% लेसर, ना ऑब्विसली इट विल नॉट बी नेवर बी लेसर. बट लेसर म्हणजे काय होतं? N2 is equal to 0.95 टाइम्स ऑफ N1 असं झालं असतं ना ते. हे कळलं का तुम्हाला? ओके, हे झालं. त्याच्यानंतर FC1 कॅल्क्युलेट करा. व्हॉट इज FC1? सी, at least you will get 2 to 3 marks if you write this stuff and calculate FC1. So for calculating the FC1 you are having at least 2 marks. FC1 1 mark, FC2 2 marks. So what is M? M is equal to 1 kg, omega 1 is equal to 37 and R1 is equal to C, radian per second, kg, unit बघा काय आहे, kg multiplied by radian per seconds multiplied by meter. Then and then only you are getting FC. Okay, so what is you are getting FC? FC you are getting 106.6 Newton. समजलं इथपर्यंत? भावना तुम्हाला प्रॉब्लेम समजला का? आता ह्याच्यामध्ये त्यांनी 3 पोर्शन दिलेले आहेत, N, N2 आणि N1. So we have to solve for all these 3 positions. Okay, and now they are saying find, neglecting the obligatory of arms, initial compression of the spring and equilibrium speed corresponding to the radius of rotation of 100 mm. Okay, initial compression of spring and equilibrium speed corresponding to the radius of rotation. So this is what I have. Is it okay? Okay, have you understand this problem, guys? Have you understand? So now this problem, which problem I have solved? Okay, this is an easy problem. I think I have solved. Okay, I was supposed to solve this problem. That is okay. Chalo. No problem. Okay. Chalo. Now, guys, what is the next step? FC2. Find out, calculate the FC2. Now, initial compression of the spring. Okay. Now, this is what. Now I have. Do you want the diagram? मला सांगा तुम्हाला डायग्राम पाहिजे ते बाजूला. डायग्राम पाहिजे की डायरेक्टली हे इक्वेशन तुम्हाला लिहिता येईल, समजेल? मला पटकन सांगा. आता आपली इनिशियल कॉम्प्रेशन ऑफ द स्प्रिंग कॅल्क्युलेट करायचे. तुम्हाला ही मिनिमम पोझिशनसाठी आणि मॅक्झिमम पोझिशनसाठी हे इक्वेशन तुम्हाला डायरेक्टली लक्षात राहील की तुम्हाला डायग्राम पाहिजे बाजूला? बरं पटकन सांगा जरा, आपल्याकडे वेळ कमी आहे. हे इक्वेशन आहे ना, टेकिंग मुवमेंट, हे इक्वेशन तुमच्या लक्षात डायरेक्ट लिहिलं तरी ते मी चालेल का, की तुम्हाला डायग्राम पाहिजे बाजूला? ठीक आहे, तुम्ही म्हणत सर मी डायग्राम काढतो. काय डायग्राम काढणं काय कठीण नाही, बघा व्हेरी सिंपल. हा, ओ पॉईंट काढायचा. मिनिमम पोझिशन म्हणजे काय? ही. ओके, इथे काय FC1 येणार आहे. ओके, आणि इथे काय येणार आहे? R. बघा मी डायग्राम कशी करतो. हा तुमचा पॉईंट R1. इथे कुठला फोर्स ऍक्ट होतो? mg प्लस h2 डिवाइडेड बाय 2. ओके, हे डिस्टन्स किती आहे? x. हे डिस्टन्स किती आहे? y. आता ऑब्लिगेटी इफेक्ट त्यांनी निग्लेक्ट करा म्हटलंय ते mg कन्सिडर करायची गरज नाहीये. सो टेकिंग मुवमेंट what you are getting? mg plus h12 into y is equal to fc1 into x. क्लियर झालं का? Very simple. Okay, so calculate. So from this you are getting S1. Okay, so from your this getting your S1. आता पुढचं सोपं आहे. Okay, so S1 is equal, so now m is equal to 0. Capital M is equal to 0 because they haven't given you the m. So mg plus S1. So this term will get 0. So you are getting S1 is equal to 2 epsilon upon x upon y. So you are getting this. Okay, now for maximum equilibrium position. For maximum equilibrium position, what is the diagram? How will you draw the diagram? Can anybody tell me? Again, same. See how I am drawing a diagram. Draw these two vertical and horizontal lines. Okay. For maximum position, this will be outwards. Okay, this will be what FC2. Okay, this will be what mg. But here we are neglecting a mg. Remember, this is the R2 point, and here you are getting mg plus s2 divided by 2. Very simple. Okay, this is the x and this is the y. Okay, and this is pi is the head circle. This is the h2. This distance. Okay, is it clear? So it is very easy to draw the diagram, neglecting the effect. Okay, so neglecting the effect, you need this much only diagram. Now write down the equation. Now write down the equation. For maximum position, what is the equation? Mg plus h2 divided by 2 multiplied by y is equal to what? FC2 into what? X. Guys, now message me fast. Have you understand how to draw the maximum and minimum equilibrium position diagram and how to take the moments? मला फक्त एवढं सांगा बाळांनो. जर एवढं क्लिअर झालं ना तुम्हाला की डायग्राम कशा काढायच्या, की बाकी सगळं सिंपल आहे. इज इट क्लिअर? हॅव यू अंडरस्टँड? मागच्या प्रॉब्लेमला केलं तसंच. मिनिमम डायग्राम ड्रॉ करायची, मॅक्झिमम डायग्राम ड्रॉ करायची आणि मोमेंट घ्यायचा. मग मोमेंट घेतल्यानंतर तुम्हाला काय मिळणार? S2 मिळणार. What is S2? 705.6 Newton. Okay, so you got S2. Now what is H? This is a basic formula. H is equal to R2 minus R1 upon Y upon X. Bada, what is the step? What is the step? First of all, draw minimum diagram, take moment, find S1. Draw maximum position diagram, take moment, find S2. Then find H. Okay, R2 minus R1 upon Y. So before that, find FC1, FC2, R1, R2, हे सगळं फाइंड करायचं तुम्हाला बिफोर दॅट, अँड देन फाइंड S1 and S2, and then find H, and then find K. Okay, so now what is this? This is K actually. This is K. What is K stiffness? S2 minus S1 upon H. Okay, H आपण ऑलरेडी फाइंड केलाय, सो H फाइंड केला, K फाइंड केला. ओके, आणि मला काय मिळालं? K मिळालं. नाउ इनिशियल कॉम्प्रेशन ऑफ द स्प्रिंग. Initial compression of the spring means what? Initial compression of the spring is equal to S1 upon K. This is the formula. What is S1? S1 is the spring force. S1 is the spring force exerted at the initial म्हटलंय ना, initial compression of the spring. मग ते कॅल्क्युलेट करण्यासाठी you have to consider S1, that is a spring force exerted at minimum position divided by upon K, that this is nothing but the K is nothing but a stiffness. Okay, so slightly this is another type of problem, same, but here they have told to find out the initial compression of the spring. Okay, is it clear? Now last part, they have told you to find the n. आता त्यांनी काय सांगितलं शेवटला? Find out the n when r is equal to 100 mm. Means what? They have told you to find out the mean speed, mean equilibrium speed when, this is a case number 2, actually guys, this is a case number 2, when r is equal to 100 mm. So now tell me, how will you find? You have this equation. आता हे इक्वेशन मगाशी आपण डिराइव्ह केलंय. हे इक्वेशन कसं लक्षात ठेवायचं सगळ्यांना माहिती आहे. FC2 minus FC1 हे कसं लक्षात ठेवणार तुम्ही मला सांगा. हे इक्वेशन कसं लक्षात ठेवणार? मॅक्सिमम, मिनिमम, मीन आणि मीन. मॅक्सिममला काय असतं? FC2 R2. मिनिममला काय असतं? FCR. आणि मीनला काय असतं? मिनिममला काय असतं? FC1 आणि R1. ओके बाळांनो, हे इक्वेशन कसं लक्षात ठेवायचं ते सांगतो. हे इक्वेशन बघा. पहिल्यांदा काय घ्यायचं? मॅक्सिमम आणि मिनिमम. आता याच्यामध्ये ग्रेटर कोण आहे? मॅक्सिमम. सो FC2 मायनस FC1 आणि R2 मायनस R1. सिमिलरली नंतर काय घ्यायचं? मीन आणि मिनिमम घ्यायचं. मग कसं घेण्याचं? ग्रेटर कोण आहे? FC. सो FC मायनस FC1, R मायनस R1. सो R मायनस R1. आणि शेवटला FC2 मायनस FC, म्हणजे हे दोन घ्यायचे. FC2 मायनस FC आणि R2 मायनस R1. And then you will get this equation. आणि ह्या इक्वेशन वरनं you can find out n when R is equal to 100 mm. गाइस हे क्लिअर झालं असेल तर मला मेसेज करा. ओके, इज इट ओके? आणि मग काय करायचं? ह्या इक्वेशन मध्ये सगळं पुट करायचं. आणि ह्या इक्वेशन मधनं तुम्ही पुट केलात ना सगळं, की तुम्हाला कुठलेही दोन इक्वेशन वापरा, तुम्हाला काय मिळणार? FC मिळणार. what you will get? You will get a FC. हे कशासाठी मी केलं? FC कॅल्क्युलेट करण्यासाठी. आणि FC इज इक्वल टू एम आर ओमेगा स्क्वेअर. त्याच्यावरून तुम्हाला ओमेगा मिळणार आणि ओमेगा वरनं तुम्हाला काय मिळणार? एन मिळणार. आणि ओमेगा वरनं तुम्हाला एन मिळणार. Okay, so this is how we have to solve the problems. So these are the two problems. One more problem I will take tomorrow.